Next, I'm going to show you some features which are not present in 210 and 212. So that is the counter function. So if you look at the documentation, it says NTAg 21X, that is 213, 215 and 216. It has got a 24-bit counter, and this counter increments on the first read or a fast read command. We're going to see what exactly it means. And this is like a one-way counter. It always increments, it never decrements. And if you go down the documentation, it also speaks about what happens when the counter reaches its limit. When all the 24 bits reaches the value FFFF, the counter will not change anymore. And one more interesting thing about the counter is the counter has to be enabled before you want to use the counter feature. So that is controlled by a bit in the configuration page, which I'm going to show soon. And we can also protect the counter by means of a password. So the two things here, the first is the counter has to be enabled, and you can also protect the counter by a password so that nobody can read without a valid authentication. A new command is introduced, which is called as the read counter command. So here, so basically you can read the value of the counter by either issuing a read CNT command, or you can also see the counter value by means of the NFC counter mirror, which we are going to see soon. So if you go to the sections where the configuration pages are described, so these are the two configuration pages. If you see this, the access byte, the access configuration byte. So we know what is the prot main. The prot is, which is also present in 210 and 210 and 212, which is the protection, whether it's read or write protection. And these two bits are present only in 212 onwards. So the fourth bit is called NFC CNT enable, and the third bit is called NFC CNT password protect, and we're going to see how to use these bits. So I'm going to connect my box. It's connected to COM49, and I'm going to try this experiment using NTAg 213 and click on the go. So in order to see the current configuration, you have to click on the configuration tab, and as you can see here, the NFC counter is disabled. So what you see here is the encoded decoded values of the configuration page. So the counter is not enabled, and the counter is also not password protected. So let's try to see the value of the counter. So in this version and signature tab at the bottom, I've introduced a section called the counter, and if you click on the read button, I'm going to issue a read counter command and see what happens. So you get a failure. It's because the counter is not enabled. So it'll stop again, start again, click. So this time I'm going to enable the counter first. So go to the configuration page 1 and enable the value of the counter and write. So the write is successful. So if you try to click on a read now, it still shows error because whenever you change the configuration, it will be active only after you start the tag again. So just going to place it back. So click on read. You can see that it has got value 1. So the first time, because after we enabled it, we read. So when I clicked on a go command, so as the documentation says, the first read command will increment it, and after that you can read any number of times. The counter will not increase at all. So it is the first valid read after the RFID enters this RFID field. So let's try that. Stop. I'm going to place it again. Select, and now we should get, this is the old value, and if you click on read, you should get 2. So what we understood is the every valid read command, sorry, the first read command will increment the counter. So you can read 100 times, but the counter will never increase 100. So it is only incremented when you place the RFID card for the first time. So next thing is about, we'll see how to password protect it. So to do that, you have to first enable the password, and keep in mind, before you enable the password, you have to have a default, or you have to set the password. Don't assume that the password is all zeros when you buy a new NTAg. So I'm going to change the password to 1234. I'm going to write the password, right, and also going to write the password acknowledge, which I'm not using here, but just write it. So my both password and password acknowledge is now 1234. Again, password will get active only when you use the card for the second time. So click, select, go. Okay, so I have enabled the password, and however, just try that, sorry. Okay, now sorry, I've set the password, so let's go and enable it. Okay, so before that, let's give it a try. Let's go and try to read. So I get 3, that means read is successful. So this time I'm going to enable or set the value of the bit NFC counter password protect to 1 and say write. So I'm going to start again. Click on a select. So click on a go. So if you see there, NFC CNT password protect is equal to 1. So if you try to read, you get a failure because we have protected the counter. So stop and start again. So this time I'm going to authenticate. So we know the password is 1234, and authenticate is okay, and we'll try to read, and you got this number 10. So that's how you can protect the counter, and you can read after successful authentication. The next feature I'm going to show you is the mirroring, and to do that I'm going to unprotect for a while. Unprotect, right. So what I have is, the counter is enabled, but it is not password protected. So I'm going to show you about the mirror config bit in the configuration file. So as you can see here, so this is part of the configuration 0, which is present in the bit 6 and 7, and because it's a 2-bit value, it has got 4 combinations. 00 means no mirroring at all, and 01 means a UID ASCII mirror, which is very similar to NTAg 210 and 212. 10 means the NFC counter ASCII mirror. So just like mirroring a UID, you can also mirror the value of the counter. And 11 means, so mirror both UID and the NFC counter. So we know that NFC counter is a 24-bit value or a 3-byte value, so it needs 6 bytes of ASCII to store it. And there is some good example in this document about the mirroring. So if you go to ASCII mirroring section of this document, so it's a nice example. First we'll go to the example, then I'll show you how it is done. And just like we had in 210 and 212, you have to indicate where the mirroring starts. So you have to specify the page and the byte address of the page, and you have to make sure that you have got enough memory wherever the mirroring takes place. Say you need 14 bytes for the UID, and you need 6 bytes for counter, plus you also need one byte which is a separator. So this is the first example which speaks about just the UID mirroring. So you have to identify where this value zeros are. So it's present in from page 12 onwards here. So if you set the value of the page and the byte to 12 and byte as 1, so from this point on the UID mirror happens. So the next example is this, where shows where the UID is mirroring. The next example is about NFC counter mirror function. So in this example we have got just the counter. Say you know that it needs 6 bytes. So if you set the value of the mirror to page number 12 and byte 1, and you can see that these 6 bytes will be replaced by the value of the counter. So for example, if the value of the counter is 3, probably it's not 3, if the value of the counter is 003F31, then this is how the counter mirror takes place. So it occupies 6 virtual bytes. When you've got both UID and NFC counter mirroring, you will have values of UID and the counter. And for example, if you see here, you got the first 14 bytes as a UID and the last 6 bytes as a counter, and between that you got a separator. And as you can see here, after this UID mirroring after UID and NFC counter mirroring, you can see that the values of UID and NFC counter present. So let's see how we do this all this mirroring with our N1 NTAg 213. So I'm going to stop and start again and give a go. Alright, so the mirror config is in the config page 0. I'm going to set this as just the UID, and I want the mirroring to happen at page number, I would give 6 and the byte number 2. So it's starting from here, right? Okay, so let's try to refetch the entire data now and see what happens. So as you can see here, the mirroring did not work at all. So looks like we have to stop and start all over again. Yeah, if you see here, there's some more data has come in here. So if you give the ASCII, you can see that we started our mirroring from here, byte 2. So 046440 B2. So these 14 bytes matches the 7 byte UID. So next I'm going to show you how to use the counter mirroring and counter and UID both mirroring. So I'm going to connect my box and click on a select. So the current configuration is set to the mirror config as 1, which means the UID mirroring. And if you see here, the value of UID mirrors from page 6 and byte 2. Let us go and change this to counter this time, and before that we can see what is the current value of the counter, 68. So go back, set to counter 2 and say write. So we know that something has written. So in order to see the effect, we have to stop and start again. So the mirror config is set to 2, and somewhere here we have got the counter values. If you go to the ASCII mode, you can see that the counter value takes 6 bytes starting from page 6 and byte 2, and the value is 45, which is the hex equivalent of, let's see what is the current value here, 69. And the last one is we'll see both UID and the counter set and a write, and to see that you have to stop and select again, click on a go, and we can see that starting from page 6 and byte 2, all this information is about the UID and the counter. And as the documentation says, the UID and the counter, they are separated with the X mark, as you can see here. So we have seen all the three different types of mirroring, and you have to keep in mind this mirroring is just a overlay on the existing memory content. So in other words, this is a kind of a virtual memory, and because if you set it back to no mirror, you should see the original data you had in page 6 byte 2 onwards. So right, you're going to revert back to no mirror, stop and start again. So there is no mirroring here, so all this information is clean back to 0.